folks, welcome to your first set of ICP video notes for the second semester of ICP. Today we're going to be talking about matter. So, what is matter? Matter is anything that takes up space and has a mass. All matter is made up of tiny particles, which sometimes we call molecules, but that won't become important until later in the semester. A state of matter is the condition of matter or the form that the matter exists in. Basically, a state of matter describes the way in which those tiny particles are arranged. The three states of matter that exist on Earth are solids, liquids, and gases. This is a handy little chart here that you should probably copy down in your notes. For each state of matter, this chart shows you the particle diagram, and it gives you a description of the way the particles are arranged, how the particles move, and how close together they are. So let's break that down a little bit. In a solid, the particles stay in one position, although they do vibrate a little bit back and forth. They don't actually move around very much. They're stuck in their one little spot. So those particles are arranged in fixed positions that are very close to each other. There's not a lot of space between particles in a solid. Since those particles don't move, the substance keeps its shape, so a solid doesn't change its shape. And since they are close together and they don't move, the volume is very easily measured. Liquids are similar to solids in that the particles are very close together, but they're no longer in fixed positions. In a liquid, those particles can slide right past each other and move around just fine. Since those particles are able to move around, the liquid doesn't keep its own shape. It takes the shape of whatever container it's in. And since there's still very little space between particles, we can measure the volume just fine. Now, gases, totally different ballpark. They're not similar to solids or liquids in very many ways at all. The particles in a gas are extremely far apart from each other in comparison to the size of those particles. And the gas particles are always moving around, often very quickly. Since those gas particles are moving, gases don't keep their own shape, and since there's a ton of extra space between the particles, any change, even a slight change in the temperature or the pressure of the gas will change the space between the particles, which thusly changes the volume. So because of that extra space, we can't really measure the volume of a gas. Okay, let's look at an example here that goes through the three different states of matter and why they're arranged in the way they are. Fair warning, I'm about to be using the words particles and molecules interchangeably. Particles is like the broader term, molecules is a little more specific. So don't get confused when I use those in the same way because they're basically the same thing. So, water. It's a very simple molecule. You get two hydrogen atoms and an oxygen atom stuck together and boom, you've got a water molecule. The way in which those hydrogens and the oxygen are bonded causes the hydrogens to have a slightly positive charge and the oxygen to have a slightly negative charge. As you know, with magnets, positives and negatives attract each other. So when you have a whole bunch of water molecules around, they naturally have a certain amount of attraction between the molecules because of those slight positive and negative charges in the atoms. That attractive force between the molecules is what holds them together. Depending on the amount of kinetic energy those molecules have, reminder that's called thermal energy, the kinetic energy of particles, those molecules might actually stick together. In other words, if the molecules are moving slow enough, those forces of attraction will be more powerful than the kinetic energy, so they stick together. If those particles are moving too fast, and the kinetic energy is greater than the force of attraction, then they won't stick together. All right, let's start with solid water. For those of you who don't know, that's called ice. It's not very easy to squish ice down to make it any smaller than it already is because it's a solid and there's not a lot of room between those particles. You can measure the volume of a piece of ice, and since the ice is cold, the thermal energy of the particles is relatively low in comparison to the force of attraction between the molecules. Since the molecules have a low thermal energy and they're not moving around very much, those attractive forces take hold and push those molecules even closer together. That's what helps a solid keep its own shape. As the ice warms up and starts to melt, it gains thermal energy and becomes a liquid. The more thermal energy those particles have, the harder it is for the attractive forces to be the stronger forces in this case. So then the particles are able to move past each other just fine, which is why liquid water doesn't keep its own shape. So the particles in a liquid are still very close together and we can't compress them, but they don't keep their own shape because they move past each other, which helps us to be able to measure the volume still. If you heat that water up and boil it, the water particles will move very far apart from each other, becoming water vapor or gas. The particles of water in vapor have a high amount of kinetic energy. They're moving very quickly past each other. So much so, in fact, that the attractive forces are pretty small in comparison to the thermal energy of the particles, so the particles don't stick together. At this point, the particles are moving around and flying so fast that even when they do get close together, the attractive forces don't take any kind of hold to them. It's kind of like when you take two magnets and move them slowly past each other versus when you take two magnets and move them really quickly past each other. When you move them very quickly, the magnets are less likely to hold on to each other. So since those particles are moving, the gas doesn't hold its own shape, and since there's a whole bunch of extra space between the particles, we can very easily compress that gas down or make the particles move faster by changing the temperature or adding or subtracting pressure, and changes the volume so much that it's really hard to get an accurate measure of what the volume actually is. You might have heard of compressed gas or compressed air. That's a real thing. You can take a whole bunch of air and compress into a little tank. Because gas has a whole bunch of extra space in it, you can compress that down. Well, that's it for today, folks. I hope that you had a nice review of the states of matter with a slightly different perspective than you probably heard before.